day, and I am here today to discuss about stacks. Our activity 1 was to write and assemble a program to load the values into each of the registers R22, R24, then push each of these registers into the stack. Single step the program and examine the stack and the SP register after the execution of each instruction. So we are given here the code and we will just execute it in the ABR. So here is the ABR and we are going to execute it and explain each one by one. So we can see here that LDIR20 is loaded with high RAM end. What is RAM end? RAM end represents the last RAM location, and it is loaded with high. That means that the LDIR20 is loaded with the high byte of the RAM end into R20. Then it is being output at the stack pointer high right here, and then again LDIR20 is loaded with low RAM end. That means it is loaded with low byte of RAM end into R20, then outputted into a stack pointer low or SPL R20 into R20. So if we execute it, next is we load the values of R20 with the value of 20, R21 with the value of 31, R22 with the value of 42, R23 with the value of 53, and lastly R24 with the value of 64. Push. Okay, this is the push, and as we push data onto the stack, the data are saved where the SP points to, and the SP is decremented by 1. As you can see here, SP is stack pointer is at 0x085F 8085F. So as we push it, it will decrement from F to E, then D, then C, then B, and lastly is A. That's activity number 1. Activity 2. Write and assemble a program. A is to set the stack pointer into $9D. B, put a different value on each RAM locations. And here, 9D, 9C, 9B, 9A, 99, and 98. Letter C is pop each stack location into the register R20 to R24. Then letter D is to use the simulator to single step and examine the register, the stack, and the stack pointer. So we're going to load that program into the ABR. Okay, then we're going to run it. So we are going to execute it. First, we put LDIR20 into high, which is the stack pointer. We will set it to 9D and output it in SPH. Then next is we are going to put R20 again to low and and put the value of it with 9D and output it in SPL. And as you can see, it is here 9D, and we are going to load the following data: R16 with a value of 1, and it is STS. This STS is a command instruction to directly store the data to the direct space or into the memory. Okay, then we are going to execute it all with the following value of R16 with 2, R16 with 3, and we are going to overwrite it then with the value of last one is R16 with the value of 6 and directly stored in the 9D. So we're going to pop it. Okay? When we pop the instruction, the SP is incremented. It is the opposite of the push. And the top location of the stack is copied back to the incremented back to the register, and that means the stack is in LIFO or last in first out memory. So we are going to pop it, and as you can see, this is 9E, and it is said to be increasing, so the next value should be 9F, then A0, A1, and lastly is A2. That's all.